Dear students, Assalamu alaikum. Today we will start chapter number 8 of our course, Artificial Intelligence. The chapter is regarding first order logic. In chapter number 7, we introduce the logical agents and we have discussed the propositional form of logic. So here we will discuss the first order logic. Normally we call it FOL and we also call it predicate logic. The topics which we will discuss in this lecture is regarding the importance of FOL, why we use FOL, if there are other forms of logic, why we are describing here the predicate logic. Obviously, whenever we talk about logic, it is also important to know that how you write sentences in logic. So here the syntax is also relevant. Syntax is also important. So we will see in this lecture that how we can construct sentences using first order logic. And the third part is regarding the semantics of FOL. That means how you will evaluate the truth value of a sentence, because as we have seen in the propositional form of logic, that whenever we explain any form of logic, it is important that we must have the understanding of both syntax and semantics. It means the representation of the sentences and as well as the truth value of the sentences, or you can say the evaluation of those sentences, whether those sentences are true in the given circumstances or they are not true in the given circumstances. So we will see this in this chapter. Pros and cons of propositional logic. So logic itself is a language. So we have various form of logic. So in the chapter number 7, we have discussed the propositional form of logic. And every logic has its own pros and cons, some positives and some negatives. And therefore, we must know that which logic is more suitable for representing our problem. So here we will see that what are the pros and cons of propositional logic. Number one, you can see that propositional logic is declarative in nature. So it's a declarative sort of representation. That it is not a procedural representation. All the representation is basically corresponds to the given facts. And if you remember that whenever we have any representation on any fact, normally what we do is we associate it with the symbol and then we process those symbols. So all the information itself is declarative in nature. Number two, propositional logic allows partial, disjunctive, negated information, unlike in other data structures, because there we have various facts. So all those facts are separately represented. They are disjunctive in nature. And sometimes it gives you the partial information because you don't have the complete information about a fact, but you have a given fact and therefore you have to represent it. So therefore we say that we can, in propositional logic, you may represent partial information or disjunctive information. Propositional logic itself is compositional. When I say compositional, it means that you can combine various symbols together to form sentences, because all the representation is not only complete while you describe the symbols, but the important thing is that how those symbols combine together by using various connectives such as and, or, not, and other operators. So there, whenever you combine those symbols together, you always form a compositional statement such as P and Q, or R, so on and so forth. Number 4 point here, you can see that in propositional logic, there is one thing which we must know, that it is context independent, because there is no relevant information or detailed information available in the given fact. Therefore, normally we call it context independent. For example, if I say that a number is a number is bigger than this number. So the context is not there. How many numbers are there, why we are comparing those numbers. So that information is missing. For example, if I say that the ball is green, again, it is context independent because we don't know exactly which ball we are talking about and in which context that ball is being defined. So as soon as we have a given fact, we may represent the fact. So the context information is normally missing while we are representing in the propositional form of logic. We have a sentence and we represent it. Uh, but if we explain the same sentence in a natural language, we always interested to write in detail about the facts and the meaning of course is related to that particular context. For example, if I say the balance in the account is this, so in proposition logic there is no information beside this, and of course there is no information ahead of this. We just represent the fact, but a lot of questions comes into our mind. Which deposit we are talking about? What was the previous deposit? Whether it is lower than the previous or is higher than the next deposit statement, so on and so forth. So again, the context is irrelevant in propositional form of logic. And the last thing about the propositional logic, that propositional logic has a very limited expressive power. When I say expressive power, it means the power to represent the sentences. Even like in natural languages, let's suppose if you want to represent something or you want to explain something, let's suppose in Urdu, you know exactly which words can be used, uh, how we can describe the context, how we can explain the situation. Similarly, in logics, we have the expressive power. So in propositional form of logic, we only have the symbols. And what we do is we combine those symbols together and we'll see whether those sentences are true or false in a given situation. So therefore, we can say that the propositional logic has a limited expressive power. Uh, for example, one deficiency in the propositional form of logic is that let's suppose if you want to describe a generalized statement, you do not have any expression available in the proposition form of logic to do this. For example, if I want to say that all men are mortal, so there is no separate representation of this sentence. What you can do is you can just have a single alphabet, you can relate it to that particular fact, that's it. You cannot describe this statement generalized statement, although you can describe the localized statements. Let's suppose you can, in the Wumpus world problem, you can say that there is a pit in 1-1. Yes, you can say this. Or you can say this, that a breeze in 1-1 caused pit in 1-2. Yes, you can say this, but you cannot say that pit caused breezes in adjacent square. Why? Because it is a generalized statement. So in case of generalized statements, the propositional logic has that deficiency and it cannot describe that thing. Now we come toward the next form of logic, which we will discuss right now, is called the first order logic. We also call it FOL in short. And the other name of this logic is called predicate logic. So whenever I explain these terminologies, please try to understand they are same thing. First order logic, or we call it FOL, or we call it predicate logic. Whereas propositional logic assumes the world contains only the facts. First order logic assumes the world contains something more. So what is the first difference between the first order logic and propositional logic? In propositional logic, we only deal with facts. And what we do is we assign symbols to those facts. That's it. We do not go inside to those facts and see who is involved, what is the relationship they have. But in FOL, yes, we will see when we want to represent a fact, we will observe that what are the objects which are involved. Objects might be the people who are involved. Object might be houses, might be numbers, might be name, might be colors, might be games, might be centuries, might be watts. All of these are considered as objects. Let's take an example, two or three examples to understand this thing. For example, if I want to represent a fact that x is greater than y. Let's suppose I'm talking about two numbers, one is x and one is y, and the statement is, the fact is that x is greater than y. So here the objects are numbers, and there are two numbers which are involved. One is represented by x and the other one is represented by y. Let's take other example. For example, if I want to say that Islamabad is the capital city of Pakistan. Let's suppose if I want to represent this statement in FOL, I have to see which objects are involved. So there are two objects which are involved. One is the Islamabad itself, and the second one is the Pakistan, which represented. There are two objects which are involved. Let's take another example. Let's suppose if I say that even the sometimes, let's suppose if I want to say the ball is red. So the ball itself here is an object which I am referring to. Or if I say there are two balls, one is red, one is green. So here I'm talking about two objects. Both objects are balls. Okay. So in FOL, we will see that which objects are involved, number one. Number two, we will see the relations. The relations are obviously is related to those objects. What relation they have. Let's suppose I just said that x is a number, y is a number, and I said x is greater than y. So it means they have the relationship. What is the relationship? That is greater than. It means x is greater than y. For example, I've just given you a statement that Islamabad is a capital city of Pakistan. So what is the relationship between Islamabad and Pakistan is that Islamabad is the capital of Pakistan. So the relationship is a capital city or capital. So therefore, here we will also see what type of relations which are involved. I have given one more statement before that a ball is red. Here the ball is the object, but sometimes the properties are also represented in terms of relation. So red is a property which is attached to the ball. So here the relationship is with the property that is red. So that is called a relation. So it might, the relation might takes only one object, or it might takes more than one object, depending on the situation. Let's take another example, that if I say that for example, that Farooq is a brother of Babar. Farooq is a brother of Babar. So Farooq and Babar are the objects, and what relation they have? They have a brother relation. So in a sentence, we'll try to understand which objects are involved, how many objects are involved, for example, how many different objects are involved in a particular fact, and what relations they have. Sometimes we have a single relation, and sometimes we have more than one relation in a given sentence, depending on the fact itself. So here you can see various examples of relations. For example, red, round, prime, sister of, brother of, bigger than, has color, part of. All of these things can be represented in terms of relation. For example, if I say that Amin is a student of Dr. Nadeem. So here the objects are Amin and Dr. Nadeem, and what relationship they have? That Ali is a student, Amin as a student of. So the relation itself is here is the studentship, which is between these two objects. Function is something normally is the same thing as relation, but we distinguish it with the relation is only in this way, that here we talk about a single argument. So if we have multiple argument, normally we use relations, otherwise functions, but both things are same. There is no need to confuse yourself. So even you will represent it in terms of relation, or you represent it in terms of function. So in FOL, now remember that first we have to describe the objects, and then we will see what relations or functions they have. And those functions or relations are represented in terms of a predicate. For example, if I say that, for example, if I say that x is greater than y, so the greater than is a relation. So I convert this into a predicate. So I will write greater than, then bracket open, x comma y, bracket close. Now that is the representation of this sentence. For example, if I say that Ali is a brother of Usman, so brother is the relation, so that will be converted into a predicate. So I will write brother as a predicate, and in the bracket I will write Ali comma Usman. So it means that is the representation, that is the way which we represent. Unlike in the propositional logic, propositional logic में हम ये नहीं करते थे. There we represent the whole sentence, whole fact with a symbol. Here we are interested to know the objects and the relations. Now, what are the what are the ingredients of the syntax? Now it is very important to know, because whenever we are understanding any form of logic, it is important to understand the syntax. So what syntax are involved over here? It includes the constants. In number of examples, I mentioned you names. I mentioned Islamabad, I mentioned Pakistan, I mentioned Ali, I mentioned various other names as well. So all of these are termed as constants. So you can use constants if there is a representation of constants in the facts. What are predicates? Predicates are the relations or even the functions we have. We convert them into the predicate. So whenever we are transforming sentences into FOL, so at the first step, after determining the objects, or then we write down all the predicates which are involved so that we can build sentences. Next is variables. Like in all other languages, we use variables, and normally variables are used when we want to instantiate more than one values. So let's suppose I just mentioned you a statement that x is greater than y. So let's suppose x is a variable, y is a variable. So it takes any value, but what value will hold? That x is greater than y. So you can use a variable as well, not necessary that you always use constants. So if you want to make such a statement, yes, you can make such a statement using first order logic. Then we have the connectives. So all these connectives are known to you. These are and, or, not, implication, and by implication. So all of these are what? These are called connectives. And obviously we need connectives because various sentences are combined together. Yes, it is possible that we have a conjunction of two sentences. Let's suppose if I say that for example, that Ali is a brother of Y, and Ali is a father of this. So what I did, I combined two predicates together. So there, because there is and involved, so it means I have to use the and connective. So you can combine those predicates together to form a complex sentence. Then there is another operator which is available in FOL, that is called equal to. Yes, you can equate any two terms. Let's suppose one is the capital X comma Y is equal to capital Islamabad comma Pakistan. Yes, you can equate it. For example, greater than X comma Y is equal to greater than 2 comma 1. So you can equate any two terms. Equal to is also available in FOL. And then the most important thing here is the availability of universal quantifiers. And these universal quantifiers give you the freedom to represent generalized or universal statements which were not available in propositional form of logic. So here there are two quantifiers which are available. One is called for all, that is called universal quantifier, and the other one is called the existential quantifier. Normally we call it there exist, or we call it existential quantifier. So there are two quantifiers which are there. One is called for all and the other one is called there exist. For all is used whenever a given statement is true for all the objects, or it will hold for all the objects. Let's suppose I have for example, I made a representation of marks of the students on the notice board, and let's suppose if all the students are pass in the course, so rather than representing in this way that Ali is pass and Ahmad is pass and Fareen is pass and Saima is pass and Samir is pass, rather than this I can use universal quantifier and I write a single statement. So because that fact is true for all the objects which are there in the class. And existential quantifier is used when the fact is true for some of the objects, but not for all the objects. So if I want to say there are few students who pass the exam, here I will use the existential quantifier. And if I say all the student passes the exam, then I will use for all. So that is that is called universal quantifier. So there are two quantifiers which are there, that is for all and they exist. Okay, now the next thing which is very important to understand, that how we will construct a sentence. So in FOL, any sentence is said to be an atomic sentence if it is represented in the form of a predicate, and in the argument there may be one term or there may be more than one term, means n terms. So even if I represent, for example, let's take an example. For example, the fact is the ball is red. So red is a predicate and in the bracket I write ball. So red ball. So red is a predicate, ball is any term. So it means it is an atomic sentence. You might have more than one arguments in the atomic sentence, no problem. For example, we just mentioned X is greater than Y. So the greater than will become the predicate and in the brackets it will come X comma Y. So there are two terms now. One is X, second is Y. Okay, a term itself can be a variable, a term itself can be a constant, okay, or it can be a function. So term खुद भी constant हो सकती है और variable भी हो सकती है. अभी हमने example ली थी, एक और example ले लेते हैं. Ali is a brother of Usman. So brother is the predicate, Ali comma Usman will come in the argument. Now Ali itself is a constant, Usman itself is a constant, both terms are constants. Let's take another example. If I say that X is taller than Y, so taller is the predicate, X comma Y will come in the argument. Now X is a variable and Y is a variable. Yes, it is possible. So even there are constants, even there are variables, or even any function you want to represent. For example, if you want to say that greater than, and in the bracket you write X comma under root X. So under root X itself is a function, but it can be represented as a term. So you can say greater than bracket X comma under root X. So under root is a function which is a term, and X as a first argument, it's a variable, it is also a term. So in FOL, we can say that it is the atomic sentence. And for atomic sentences, we for further discussion, you can see this example as well, which is represented with a small model, which is called R and J, with R representing Richard the Lionheart and J is representing the King John. So there are two objects. What is the relationship between two objects? You can see it by the arrow that R is a brother of J, J is the brother of R. That has the relationship between R and J. So I can write brother bracket R comma J. Yes, I can write it. R itself is a person and J itself is also a person. So both are person. So I can write person bracket R and I can also write person bracket J. This is also true. There is another object which is there in the diagram, in the model you can see, that is a crown. Crown is not a person. So person is not related to crown, but crown has a relationship with John. Why? Because John is a king. So what is the relationship of crown with John? Is on head. So if I represent this sentence, I will write on head as a predicate, and in the bracket I will write John comma crown. So that is the representation in FOL. Similarly, left leg of R and left leg of J can also be represented. So in that way, whenever we have a given problem or a given model, we can define the sentences. Okay, so you can see yourself that complex sentences are those sentences which are built by using the atomic sentences. So complex sentences are used by using connectives. You can see S1 and S2, yes, S1 or S2 possible, S1 implies S2 and S1 biconditional S2, yes, this is possible. Similarly, we have, you can see lot of relationships which is being discussed here in the Richard, the Lionheart and King John relation. With this, I conclude this lecture over here and I will share the next lecture soon. Thank you.